Find the number of 5-digit numbers that can be formed from the digits 1, 2, 4, 6, 8 when no digit is repeated but the digit 2 and 8 are next to each other. Okay, so let me write the numbers first. It's 1, 2, 4, 6 and 8. We need to find the number of permutations. Of course, we are dealing with numbers and no digit is repeated. So remember the formula. No repetition, permutation. So just remember this formula. We will need it. So, but now the problem is this condition. They said the digit 2 and 8 should be next to each other. 2 and 8 should be next to each other. Okay, it's not that difficult. There could be two possibilities. That 2 and 8 could be next to each other. The first is like this: 2 and 8, they always come in this form because they are still next to each other, or 8 and 2, they are still next to each other. So there could be two possibilities for next to each other. So I will divide the answer into two sections and I will deal with them separately. So I am rewriting these numbers. So on the left I will write them as 1, 2, and now just remember that I am writing 8 here instead of at the end, 4 and 6. So I still have 5 digits, 1, 2, 3, 4 and 5, right? So, but I just put 8 with the 2. On the right, I will write the same, but I will write 8 first and 2 at the 2 after that. 4 and 6. Okay, so 2 and 8 are next to each other, right? On the left, the 2 is first. On the right, 8 is first, but they are together. So now to fulfill this condition, we can give them a common name, because they said this 2 and 8 should be together. Similarly, on the right, 8 and 2 should be together. So if they will be together, we can give them a single name. For example, I give them a name A, and on the right side we can call them B. So now I can write this, the given number of digits, like 1, A, 4 and 6. So, and on the right it will be 1, B, 4 and 6. So don't worry, because they told us how many 5-digit numbers can be found, because at the very end we can write the value of A as 2A, 2 and 8 together without this comma, in fact, and it will be 28. So it doesn't matter because they should be together. So now we can just find the number of all possible permutations, and size of the permutation should be 4. So here is the trick. Because we were given 5 digits, and we needed to find a number of 5 digits. So, but now I have grouped 2 and 8, and on the left side 8 and 2. So the size is reduced to 4, but you know that this A is actually not A. It has 2 digits inside. So eventually when you will replace the value of A, of course it will become a 5-digit number. So don't worry about that. So now I am using this formula NPR. So the size of the choices 1, 2, 3 and 4. So I will calculate 4P, and size of the permutation is 4. So remember, this is not 4 and 4, or the size of the permutation is not 4. Although you are doing that considering like the size is 4, but when you will get the final answer, for example a 4-digit permutation, there will be A inside, and when you will put the value of A, which is actually a 2-digit number, it will become 5. So it doesn't matter. So 4P4 means My calculator gives me the value that 4p4 equals 24. So I can make 24 permutations from these numbers, considering that 2 and 8 are together and they are hidden inside A. So it should be easy for the right side. It's the same problem, NPR and 4p4 and is 24. So I can make 24 permutations if 2 and 8 are always together, and 28 for when 8 is first and 2 is after that, because we have to calculate all the permutations when they are next to each other. So there could be two possibilities when they are next to each other. Okay, so now how many permutations you can make when 2 and 8 are next to each other? 24 for the case when 2 is first, 8 is at the 8 is after that, and 24 for when 8 is first and 2 is second in that group. So 24 plus 24, you can make total 48 permutations. Okay, now let's move to the part 2. It says that once again calculate all the permutations or the number, 5-digit number you can make from these choices, and condition is that digit 2 and 8 are not next to each other, because we have already calculated all the possible permutations when they are next to each other. Now we need to calculate how many permutations we can make when they are not next to each other. So this is quite interesting. First, I am going to calculate all the possible permutations if they are next to each other or not both together. So the given numbers are 1 to 4, 6, 8. Let me, the given number of digits 1, 2, 4, 6, 8. So now I am going to calculate all the permutations possible of size 5, of course, with no matter if they are together or not, all of them should be together. So and the number of choices are digits 1, 2, 3, 4 and 5. So 5p and the number of digits 5, so size of the permutation is 5. So let me see what is the answer. 5p5, and the answer is 120. So I can make total 120 permutations of size 5 out of these numbers, no matter 2 and 8 are together or not. This is the number of all the permutations. Maybe it includes when they are together, and it also includes when they are not together. So now how will I calculate the number of permutations when 2 and 8 are not together? It's very easy. I have already calculated the number of permutations when they are together, and the total number of permutations possible in that case is 48 when they are together. Now here I have all the permutations when they are together and when they are not together. The total number of permutation, including the permutations when they are together and including the permutations when they are not together. And here I have the number of permutations when they are together. So you can guess what could be the answer. The answer when 2 and 8 are not together should be 120 minus 48, and my calculator tells me that the answer is 72. Isn't it interesting?